to today's session, Powering Real-Time Recommendations with Machine Learning on GCP. My name is Matt Bichelle, Senior Director of Product and Solutions Marketing at Aerospike. It's my pleasure to introduce Vipul Naik, Chief Data Architect at Maven. The beauty of this presentation is that it covers a couple of areas that are near and dear to Aerospike's heart in terms of being applicable to a lot of our customers. Number one, being machine learning, powering a lot of our customers' use cases, and also being a recommendation engine, which is very powerful across industries. And the fact that Vipul runs it on GCP. So I'm really looking forward to this session, hearing about how Maven updates its ML models, some of the challenges they've had. I do encourage people to enter their questions into the session, which we'll conduct afterwards. So with that, I'll hand it over to Vipul. Vipul, take it away.
Thank you, Matt. Can you hear me fine? Okay, good. So I'm just going to give a little background on how our use case and the ML work we're doing, and then talk about how Aerospike fits in to that use case. So a bit about where I work. I currently work at Maven. It's a technology platform for publishers. It includes a CMS, ad management, revenue management, etc. Some of the sites that run on the platform are Sports Illustrated, TheStreet, History, Biography, and many others. LiftIgniter is a machine learning engine that's part of Maven. It's used for powering intelligent, personalized content recommendations on web, app, and email. And it's used on the Maven platforms and for other customers, other publishers who are customers of the technology. LiftIgniter was a standalone company for several years until it was acquired by Maven in 2020. And this talk will be about LiftIgniter's use case for real-time machine learning personalization and how Aerospike was part of that story. And that kind of dates back all the way to 2015. So we were pretty early adopters of the technology and haven't looked back. So just to explain kind of what we do, there's a couple sites. One is the Toronto Star, which is a customer of LiftIgniter. And on the right, you see the Street, which is one of Maven's sites that also uses LiftIgniter to power. And the things you see are the recommendations that are powered by LiftIgniter's technology. So our engine has to, in real time, for every time a user visits a page, it will decide what items to show and then send them back to the site to render the recommendations. So let's talk a little bit about our journey. And this goes back all the way to like 2014, when we were just kind of trying to get started. Our goals were always to be highly focused on metrics. So we wanted the content recommendations to not just look good, but also drive user engagement and customer revenue and KPIs. So get recommendations shown that users are likely to enjoy, to click on, maybe if it's an e-commerce site, to go ahead and make a purchase, which makes the users happy and makes our customers, the websites, also happy. The first iteration we did was in 2014. We used a daily pipeline to basically compute and update our ML models every day, wrote those pretty big models out to files, and then had our recommendation servers, like our API servers, read from them and update the models. But this was a pretty good technology. Like the core technology was good, but the update frequency of daily was too infrequent. So oftentimes an article would trend and we would like to pick it up quickly so that we can start showing it more, or an article would fall out of trend and we would like to pick that information up quickly. So that was one disadvantage. The other disadvantage of updating very infrequently is we couldn't do too much experimentation, because each experiment, the feedback loop would take a day. So we were losing out on that ability for rapid feedback. So with all these things in mind, we decided we wanted to go more real time. So initially we tried to hack it into our existing architecture. That got messy and wasn't very sustainable. So we wanted to do something more ambitious, more complete real-time first. So we'd still have some kind of daily jobs, but our main architecture, all the critical pieces would be real-time first. And so with real-time first, you need a data store which has good performance. There are some use cases where you need something like SQL, where you need a very expressive query language, because a lot of the business logic is handled through that query language. But our use case was more, didn't really require an expressive query language, because all our complex logic was in our application code. So what we needed to do a lot of lookups quickly to get in all the data that our application could crunch. And for that use case, we had heard of Aerospike around the time, and it seemed to be just what we needed. We wanted high performance key value store. We ask what's X, and we get back the value of X. That's kind of all we needed. And Aerospike said it can do it really well. And so as part of our real-time re-architecture, we went with Aerospike. So that was built into our system. And we stuck with it for 6 years now. We did evaluate some other solutions, but ultimately just decided to stick with Aerospike. And we stuck with Aerospike through a migration. We were initially on AWS, then we went to Google Cloud. We also made several updates to our data models, but throughout that, we've been able to make all those changes while sticking with Aerospike. So a bit more about how we use Aerospike. We're currently in two regions on Google Cloud. We were in the past in 3 regions. We went down to 2. We may go up to 3 again, depends on our geographic distribution of customers. And in each region, we have a cluster of Aerospike. And in each region, we have recommendation servers, which get requests to return recommendations. And the recommendation servers interact with the Aerospike cluster in the same region to essentially to get data from that cluster and do the calculations to return the best recommendations. The 2 clusters have basically identical data. Data is synced using a 2-way XDR, in some cases 1-way in others, but basically it's synced. Replication factor of 2 within each cluster, and daily full backups. Both clusters use the enterprise edition. So you have like a decent amount of redundancy in the data. And also speed, because we have different regions, and each region it's querying the same region. We also have, there's certain kinds of Aerospike updates that are more compute intensive. We are currently using a UDF to handle those updates, but that UDF we don't want to run on our production cluster. So we have a separate data store, a separate cluster to handle those high compute intensity updates. It's only applies to one of the sets we have. So most of the sets are pretty simple, but one of the sets is very intense to update. So we have that on a different data store, and it's XDRs to the others. As I mentioned, we were on AWS a little while ago before being on GCP. And we also at some point tried Kubernetes, and we had 3 regions in the past. So we tried a bunch of things. I'll talk a little more about those towards the end. Yeah. How much data do we have? So we have around 1 billion unique objects. So we have basically around 4 billion in total, because it's 1 billion replication factor of 2 and then 2 clusters, but unique objects are 1 billion. We have about 2 TB of unique data per cluster, 5 nodes per cluster. We regularly handle about a few thousand transactions per second per cluster, but we have capability to handle a lot more. The transaction volume isn't the binding factor, but we do like the ability that we can handle bigger spikes. At least the data store isn't the constraining factor. And we have in the past handled more objects depending on exactly our use cases, and also those keep evolving. So definitely not like the peak of what we can handle. A bit about how we run this in production. We have a very small team on the data infrastructure side. So we want to who are full-time dedicated. So we have a bunch of people, but they're mostly working on other projects. So we've kind of over the years, we've built a system around Aerospike that keeps our maintenance load pretty low. So Aerospike nodes export metrics to Prometheus. So Prometheus is kind of metrics reporting and graphing service. If any node goes down, or it's not seeing the full cluster, or it's having high latency or high error rates, we send alerts, high urgency alerts, and those propagate to our alerting notification systems. Right now we're using PagerDuty. And we also have various other lower urgency alerts to indicate various kinds of degradation. For example, if the volume of data in the cluster is growing at a rate where we think we might hit the high water marks on memory or disk, we'll send a low urgency alert. So somebody can look into it and decide, do we want to add a node? Do we want to do some cleanup, whatever? And then we have a doc which kind of describes for each alert what to do. Some of those things are more on the Aerospike debugging side. We haven't needed to use that for a couple of years now, but in earlier versions of Aerospike, we did turning on micro benchmarking, exporting logs. Sometimes we had that hardware issues. You have to restart Aerospike to add remove nodes. Again, hasn't happened much in the last couple of years, but it was more frequent in like 2017, 2018, 2019 onwards. It's kind of stopped, but good that we have all that processes. Finally, we have alerts on latencies and errors as observed by applications querying Aerospike. So basically things like our recommendation servers, those are the main things interacting with Aerospike at scale. We also have some other APIs around metadata updates. So if those servers are seeing high latencies or high error rates from Aerospike, even if Aerospike metrics aren't reporting a problem, we get alerted, so we can dig more and see, is it a problem with those servers? Is it a problem with Aerospike? Is it something network? So that's how we manage to keep things running. And we don't have a lot of maintenance overhead. So the first few years, we had to deal with issues related to Aerospike cluster every few months. This was, I think, maybe Aerospike versions 3 and lower that we were working with. And also a lot of the challenges were also cloud provider hardware issues. In the last 3 years, there have been very little ongoing maintenance effort. The entire recommendation infrastructure uses less than one full-time engineer equivalent, and most of that work is also not Aerospike driven. The challenges that we've had include hardware issues at the cloud providers. So things like cloud providers taking machines down for maintenance, or having some VMware issues, things like that. We've also had, like, over the years, those have gone down as cloud services have got more mature. Aerospike software has improved, so it's able to handle things more gracefully, and our own applications have gotten more robust at kind of, even if something goes down, it doesn't show an error to the end user. It just gracefully handles it. So talking of that last point, application robustness. So one way recommendation engines are easier than, let's say, if you're doing a payment platform or something where correctness is highly important. With recommendations, it's a bit of a fuzzy problem. We have to return some recommendation items, but it's okay if sometimes we don't return the very best. So if, let's say, we are making some calls to Aerospike and maybe some of the calls fail, that's still fine, because if at least enough of it succeeds, we can return good enough recommendations. So we don't have that kind of strict correctness requirements. We don't have very strict up-to-dateness requirements. Like if our ML is maybe 5 minutes behind, that's fine. It's just our internal goals. So that allows for some application level optimization. We have caching on the applications that query Aerospike. So each application maintains the cache, and the cache duration is tuned to the needs of how real time we want to keep things. So for example, for certain kinds of data, we keep very short cache, like a few seconds, and for some we keep caches of up to 15 minutes. So if there are some connectivity issues with Aerospike, we just don't expire the cache. We just extend it so that we don't run into an issue where we're out of items to recommend. And if some Aerospike lookups fail, then as long as we have enough stuff in cache, etc., we can return stuff. So most of the time, everything works fine. But this is just something. In the rare cases, things go a little bad, whether it's network or hardware or or our code or Aerospike server code or whatever, nothing really like is that visible to the end user. So that again keeps our headaches low, even if things go wrong. Okay, so I'll talk about a couple failed experiments. So when we transitioned from Amazon Web Services, AWS, to Google Cloud in 2017, we had heard about this cool technology called Kubernetes, which is a way to it. The goal is to kind of create this kind of layer of abstraction between our applications and the hardware they're running on. And the cloud is already one layer of abstraction, but Kubernetes creates yet another layer. And what we found was that for our use cases, that wasn't good. So we tried Kubernetes on Aerospike. We also tried it on our recommendation servers. Ultimately, we found that it doesn't fit well with both of those, whether it's Aerospike or recommendation servers. On Aerospike, the problem was just first of all, it was less performant because some of that overhead of CPU was going into Kubernetes. And then secondly, that extra layer of abstraction made it hard to debug things. If there was a problem, we needed to look into how it's interacting with the hardware. Not something we need to do often, but if we do, it's just more work. So ultimately, we got rid of Kubernetes, and for Aerospike and our recommendation servers, we haven't used it since then. Obviously, Kubernetes now is a lot more mature, has a lot more features, so these learnings may or may not apply. Another experiment we did, and at the same time, it is kind of bunched with our Kubernetes experiment, was to go to smaller nodes. So like each individual node is smaller and we have many more nodes. So the idea behind that was like, we can scale much more granularly. So instead of having to go from 5 big nodes to 6 big nodes, if each node is like a quarter the size, we have like 20 smaller nodes. We can then go up from 20 to 21 to 22, and then we can kind of go up and down in much smaller increments and be much more granular about exactly how much capacity we need. The problem with that was that there's some overhead of running a node, and that compute and memory overhead of running the node. The smaller the node is, the larger that overhead is as a fraction of the resources on the node. So we didn't actually get that much saving. We got slightly more granular scaling, but we lost a lot in that overhead. And then another problem was that frequent need for scaling nodes up and down. So that granular scaling means we are scaling up and down more frequently, but that also means a cluster is spending a lot of time just readjusting all the data each time nodes go up and down. It has to rebalance the data. And so it's spending more of its time in this lower performance state of rebalancing rather than in the high performance state, which it is when things are balanced. So finally, we switched back to using large nodes with more CPU, more memory, and larger SSDs. And in fact, in more recent years, we have even gone ahead and increased the ratio of SSD to memory as we notice that our records are getting larger. So we kind of make more efficient use of things. And yeah, I think that is it. Thank you.
Well, thank you very much, Vipul. That was a great history almost of your experience with Aerospike, not even your current experience, but really the history of it. One of the things I wasn't sure if I missed in the presentation was, what were the motivations for you guys moving from AWS over to GCP?
I think the main motivation was that they were giving us credits that would cover like about a year or more of our expenses on the platform. There was also some discussions of like other partnerships with Google and like other integration into their products. There are also some aspects of the Google platform that we liked. In particular, BigQuery was one of the like things Google had, which AWS doesn't have something quite like that. So that was one other attraction.
Well, I mean, given it was a couple years ago, how's your experience been with GCP and how are you liking it? Yeah, I guess now.
Pretty good. I think the GCP and AWS are pretty comparable overall, and both have improved quite a bit since, over the years, just as cloud platforms have matured. So definitely things now on GCP are smoother than they were on either side at the time of transition. But overall, we haven't had any regrets about moving.
Okay, well, I guess no news is good news in that regard.
Yeah.
So not a problem. Um, it's interesting given that you've acquired Lift Igniter and that they're a recommendation engine. There's a lot of other, whether it's in the ad tech or martech industry, there's a lot of recommendation engines that other Aerospike customers
Mm-hmm.
deploy on Aerospike. And so in the presentation, you talked about, the recommendations like daily wasn't frequent enough, that you wanted real-time recommendations, but it wasn't just for a customer per se, but it was also almost like you needed to almost, I'll say, span the internet for like what's a hot article or, something came in or out of vogue. I was kind of curious if you were able to net any business level metrics to say, we were able to get the right recommendation to the right user at the right time, and this meant X to the business. Is that something that you follow or are measured on, or that you're aware of in the business, given the importance of recommendation engines?
We probably did some analysis like that. It's a while ago. I think it hasn't been an issue recently in the business pitches. Like we just give the overall qualitative picture. Yeah, so I don't have any numbers off the top of my head, but we did do various analyses to say that when a new article did come up and it was trending, we were able to pick that up quickly. So we did kind of confirm that kind of quantitatively in various ways. I don't have any of those right now. I would also say that just going real time, in addition to just the benefits for recommendations, which is twofold. One is that you pick up trends quickly. The other is you can try things more. You can try more things, because if there's a feedback loop, each iteration of the feedback loop, if we can make it faster, we can experiment with different algorithms more quickly, different ideas more quickly, both automatically and any manual experimentation. So instead of like, if you're doing things daily, then in a month you can only like do 30 iterations. But if you're doing things continuously, you can like do hundreds of iterations. But another advantage is just not having a daily pipeline, just having something continuous, just makes it in some ways just easier to manage things from a DevOps perspective. I mean, it's harder to set up, but once it's running, then you can kind of reason about it more easily. You don't have to remember, oh, this job was supposed to run at 5 a.m., but it failed, so now I have to rerun it again, and that's why things got worse. And it's just like a much more like natural and continuous thing for things to just be running all the time. You can have a reason about them. You can set alerts around it more easily. So it's definitely like more upfront work to get something that's stable and continuous. But once it's there, it's like easier to reason about.
Sure. I think it makes sense that your models are running on updated data, as you say, almost continuously. But is Maven updating the models? And if like, how frequently are you actually updating the models? Like, I guess maybe I missed that.
Yeah. So there's two aspects when I say continuously. One is there's some lag. So it's not like as soon as an action is taken, it immediately reflects in the model. There's a pipeline. There's like a steps it goes through, like it goes from one place to another to another. So there is some lag, but it's still happening continuously. It's just like it's not happening instantaneously necessarily. Then there are different levels to our models. So one is just a user's own history influencing their future recommendations, and that's pretty much instantaneous, because as soon as you visit a page, we have that page in your history, and that affects our recommendation for what page to recommend to you next. But then there's another level, which is one user visiting a page. How does that affect the kind of ranking of that page for other users, based like one user taking certain actions, how long does that take to affect the sort of global model? And that has some lag because we don't need that to be totally instantaneous. It goes through a pipeline. We do some filtering out for spam or for like suspicious activity, and it may take somewhere between like 5 minutes and half an hour. It's then just vary, and we can configure that. There's another level of the first level was instantaneous user level. The other was like kind of item level, where we're trying to like use existing behavior to by some users to inform the recommendations overall. And there's a third level which is less frequent, which some of it is daily, some is even less frequent, which is the overall like model of how to think about these relationships, like how much weight to give to your history versus your geography versus your like time of day and all. There's kind of relative weighting of those things, but that's not something that will change every second. That's something that might change over time as like the world changes, as like user behavior changes, as kind of user trends, and that's something we don't need to be updating instantaneously. So different levels of update, and it's the first two levels which I said, the user's history affects their immediate next behavior, and kind of picking up the changing relationships between, and that's where we do need something that's real time enough both for updating and using, and that's where Aerospike comes in. That third level, which is like just updating the overall like how the world is, like a kind of model of the world, that's not something we do frequently enough. Like the cadence is daily, and even or some parts of it even less frequent. And there we don't really need Aerospike. We just run a job processing some data, training data. We output a model and ingest it into our servers. We don't use Aerospike for that training part itself. But Aerospike is pretty critical to the more real-time parts of the model.
Interesting. Yeah, I mean, we have customers, that do use us for both, if you will. And with Spark, we have pretty strong. You could say that we have pretty strong parallelization. So customers use us for 150 tera. They'll process the job pretty rapidly, even with the opportunity for multiple times a day. A 12-hour job turns into a 2-hour one type of thing. So could be a future, could be something to consider. So something else that you mentioned in the presentation, even though it was a failed experiment, was with Kubernetes. And given the Aerospike, I'll kind of lead the witness here. Given that Aerospike has a Kubernetes operator that was launched, not too long ago, I'm kind of curious, might you see utility in leveraging Kubernetes going forward? Would it be something that you might re-experiment with, if you will?
So this will have to be like something, I guess, that our like the DevOps and infrastructure folks in our company would kind of decide if they ever decide to experiment again with Kubernetes, then we may look at this. Personally, I don't see any compelling reason to switch to Kubernetes for Aerospike or for anything else, but I'm also like not a Kubernetes evangelist, and there's people who know much more about it and are more enthusiastic about it. So if we do get to that, we may look at this. I would say about our failed Kubernetes experiment, I think what basic mistake we made was when we did this migration, we did not consult with Aerospike about the best practice at the time. And I think at that time, at least, the best practice was like, don't use, like, Kubernetes will cause you a performance hit, and given what we wanted to achieve, it wasn't worth it. So I think we should have consulted at the time before making that move, or even just to get best practices on what to do. And obviously those best practices keep changing. And if we do consider going back to Kubernetes, we'll definitely check what the latest best practices are on your end.
Yeah, and I guess we'll wrap up maybe with this final question. It's a little bit closer to your what you work on typically. You mentioned early on before Aerospike that a lot of your query logic was in the application. I would assume that if you can move that or push that further down to the database that would help things run even faster. Could you comment on how much you've been able to kind of do that? Because
Yeah. So actually, even today, most of the query logic is in the application. What Aerospike helps us with is just the actual, like, we don't have to manage our storage and retrieval logic. We just get all the data from Aerospike. We know it's there, and then we can run whatever calculations we want to run on it. And I think that fact makes us like relatively agnostic on the exact capabilities of kind of the system we are using, as long as it's fast and it allows for rapid key value lookup. We don't really care that much. Now, I think now Aerospike probably has a lot of functionality that it didn't have in 2015 when we first started using it. And at that time, we just like didn't care much about functionality other than, yes, we can rapidly retrieve data. There's one thing where we are using Aerospike a little more, which is for updating one of the pieces of the ML. We are using UDFs on Aerospike, so it's like some mathematical formulas we are running. So it like uses the existing value of the data and the incoming input and kind of merges them in a way, and that needs some like simple mathematical operations, which we are currently doing in Aerospike. We've thought about doing it in our application, but it works well in Aerospike, so we probably just continue with that. So yeah, we do still run everything in application as much as possible, except this UDF, and that works really well. And we're not like changing that underlying logic. Yeah, we haven't felt the need to kind of try to have more of that logic on the DB side. So Aerospike probably has more capabilities around that now, but we haven't.
Yeah. So I would love to get your feedback on our announcement this week, even. I think be of great interest. So we have reached time. So again, it's really great to have long-term customers such as yourselves present at Summit. So from me and from the rest of Aerospike and to the audience for listening in, thank you again, Vipul. Appreciate it.
Yeah, thanks for having me. Bye.